Hi guys, this is Joe, and today we'll be looking at small angle approximations. We're going to be looking at how we approximate certain trig values, and we're also going to be looking at when to approximate it. So first thing first, I'm going to write out what we approximate. So sine x, when we approximate with small angles, is approximately x. Tan x, it goes to approximately x as well. Cos x is slightly different. This approximates to 1 minus x squared over 2. So for A level, we already need to know these three trig approximations. So I'm going to explain to you why this is the case. So if I first sketch the sine graph, so it looks roughly like this. And now alongside it, I'm going to sketch the graph y is x, a straight line graph. As you can see, for small angles of x, not larger ones, but for small ones, the graphs roughly overlap and look similar. That's why we can approximate sine x to be equal to x. The same goes with tan x. So if I was to sketch that graph tan x, like this, and alongside that I sketch the graph y is x again. Once again, for only small values of x, they are roughly overlapping and are roughly the same. Now cos x is the one that's slightly different. So if I was to sketch the graph cos x, like this, if I was to now sketch the graph y is x, it would not look similar whatsoever, right? So instead of that, what we do is we sketch the graph y is 1 minus x squared over 2, i.e. a quadratic graph. It's a negative quadratic graph and it goes through part 1, so it's like an upside down u. And so for small values of x, now the y's are similar and therefore we can approximate it with this term here. One last thing to note is when we are doing these approximations, remember in radians, we learned about the radian unit for angles, right? And degrees. This only works when we are dealing with radians. Okay, this is a very important thing to remember. If the angle is in degrees, then you must change it to radians and then we can approximate it. We'll look at a couple of examples later on to see this case. Okay, so let's try and solve some questions together. So when theta is small, find the approximate values of A cos theta minus 1 over theta tan 2 theta, like this. I'm going to write up here what the approximations are. So sine x was x, tan x was also x, and cos x was 1 minus x squared over 2. So now it's just a matter of identifying what our x is going to be. So in this case, it's cos theta, right? So that's going to be just x minus 1. On the bottom, now it's just a matter of identifying what x is going to be. So we have cos theta, so that's going to be just theta minus 1. Right, now it's just a matter of identifying what x is going to be. So we have cos theta, so I'm going to replace that with 1 minus, instead of x, is going to be theta squared over 2 minus 1. And that's over theta times tan 2 theta. So in this case, x is 2 theta, which means it's going to replace it with 2 theta, like this. And now we should always simplify it, so we get minus theta squared over 2 over 2 theta squared, which simplifies to minus theta squared over 4. We always want to make it as simple as possible. Let's look at part B. So we have 2 times 1 minus cos theta minus 1 over tan theta minus 1, like this. So once again, replacing it in terms of theta. So this will become 2 times 1 minus, I'm going to leave it as brackets, so 1 minus theta squared over 2, close brackets, minus 1 over theta minus 1, like this. Once we've replaced it with theta, now it's just a matter of simplifying it. So what do we get here? So we get 2 minus, we get 2, open bracket, 1 minus 2, now it's just a matter of simplifying it. So what do we get here? So we get equals to 2, open bracket, minus minus is plus theta squared over 2 minus 1 over theta minus 1. So this will become theta squared minus 1 over theta minus 1. Here I can now simplify even further by factorizing it. So this would be theta plus 1, theta minus 1 over theta minus 1, which means this will cancel out and you'll be left with theta plus 1, like so. Okay, let's try another question together. So in question 3, it says, when theta is small, show that the equation this can be written as 1 over 1 minus 3 theta. So starting off with the original equation, 1 plus sine theta plus tan 2 theta over 2 cos 3 theta minus 1. So first thing first, as we always do, replace it with theta. So this becomes 1 plus sine theta will approximate to theta, tan theta will approximate to 2 theta, and that's over 2. I'm going to open my bracket, 1 minus, in this case, our x is 3 theta, right? So I'm going to say 3 theta, and that's all squared, divided by 2, close bracket, minus 1. Once we've done this, now we have to expand and simplify. So in the numerator, that's pretty simple. We get 1 plus 3 theta. On the denominator, I can multiply this 2. So now I get 2 minus 3, or with 3 theta squared, right? So it's 9 theta squared minus 1. So this will become 1 plus 3 theta over 1 minus 9 theta squared. Once again, we can now factorize the denominator, because that will now become 1 plus 3 theta, 1 minus 3 theta, plus, and the 1 plus 3 theta at the top, which will cancel out, and you'll be left with 1 over 1 minus 3 theta, and that's what they want us to find. Okay, in part B, it says, hence, write down the value of this equation when theta is small. When they're saying theta is small, they are meaning that when theta is equal to 0. Okay, so that's one thing to note. So what I can do is plug 0 into what we found in part A, 1 over 1 minus 3 theta, which will reduce to 1 over 1, which is just 1. So for small values of theta, this equation here is approximately 1. Okay, now let's look at one final question. So in part A, it says, given that theta is small, use the small angle approximation of cos theta to show the left-hand side is equal to the right-hand side. So this, once again, same method, we replace it with terms of theta. So the original one is 4 cos theta plus cos squared 2 theta, like this. Right, so the 4 cos theta is very simple. So I'm going to open my bracket, 4 times 1 minus theta squared over 2. Plus, now this cos squared theta, I'm going to rewrite it as cos 2 theta all squared like this. It's just a different way of writing squared, right? Because now I can say it's 1 minus, in our case our x is 2 theta, so it's going to be 2 theta all squared over 2, and this is all squared as well. Once we got this, we have to simplify again. So this becomes 4 times 2 minus theta squared over 2, plus this, right, the second term, we just have to expand the bracket. So we get 1 minus 2 theta squared plus 2 theta squared over 2 squared, like this, close bracket. Simplifying further, so this now becomes 4 minus 2 theta squared plus 1 minus 4 theta squared, plus this becomes 16 theta squared over 4. And finally, simplifying it, we get 5 minus 6 theta squared. Sorry, this is to the power of 4, by the way, sorry. So we get 5 minus 6 theta squared plus 4 theta to the power of 4. And that's what they wanted on the right-hand side. Okay, in part B, it says, hence, find an approximation of this when theta is equal to 3 degrees. As I mentioned in the very beginning, this only works for radians. We are given it in terms of 3 degrees, right? So if I was to plug this value 3 into this approximation, we will get the wrong answer. Instead, what I have to do now is change this 3 degrees into radians. We learned in the radians video before, right? So we just have to times this by pi over 180, which means we get pi over 60. Once you've identified this, now I can plug pi over 60 into our approximation, and that will give us the correct answer. So for part B, I am now going to plug in pi over 60 to what we got in part A. So 5 minus 6 pi over 60 all squared plus 4 times pi over 60 to the power of 4, which I would get 4.9 8 to 3 significant figures. Right, part C, calculate the percentage error in your approximation. So percentage error is just the difference between the exact and the approximation over the exact multiplied by 100, right? So the real value is when I plug in pi over 60 into the left-hand side, i.e. this equation here. And the approximated value is the one I got in part B. So if I was to plug this pi over 60 into the real part, I would get 4.9997. We subtract the approximated one, 4.98, divided by the exact one, and multiply it by 100, leaving us with 0.32% like this. So small angle approximations is not too difficult. Just remember the 3 approximations we learned before. Make sure you identify what the x value is in terms of theta, and then simplify as much as possible. If you guys have any questions there, just comment below and we'll try and get back to you as soon as possible.